Dear students, in this session we are going to discuss what is exact differential equations and how to solve the exact differential equation. We are going to see the method to solve an exact differential equation. So first we are going to see what is an exact differential equation. We will see some definitions. So now see the first order differential equation. The first order differential equation. Say, suppose dy by dx, first order differential equation. Some example we are taking. Suppose f of x. This is a first order differential equation where y is the dependent variable and x is the independent variable, and right hand side is a function of x and y. This is a simple general form of a first order differential equation. This first order differential equation may also be expressed in the differential form. What is a differential form? The differential form. Say this is the differential form. This about differential equation can be written in the differential form. It will be like this. Suppose m is a function of x and y into dx plus n, which is a function of x and y into dy equals to 0. We call this second equation as called as the differential form of the given ordinary differential equation given by 1. Any differential equation of first order we can write like this in the differential form. So now to solve this differential form, it is very much helpful. It is helpful to know whether the left hand side is a total differential. To know whether the left hand side, this part, whether the left hand side is a total differential. So now we are going to see what is a total differential. Okay, we know that the total differential, say df of x and y. Suppose a function is there, f, capital F, and what is the total differential of the function which is depending on two variables? The total differential of a function, say capital F of x comma y of two variables is given by, see, we are going to write the total differential of f, that is df. This is called the total differential of a given function capital F. It's nothing but, first we have to differentiate this function with respect to x into dx, then this same function we have to do partial differentiation with respect to y into dy. This is called as the total differential of a given function capital F. Okay, so the student must know what is the total differential of a given. Suppose it is a function of three variables. You can imagine, suppose f is a function of three variables, x, y and z. So what is the total differential of f? df. One more term will be there here, dou f by dou z into dz. It can continue if it is depending on many variables. So overall, this is the definition of a total differential of a function f. So this you must know. Now the definition. What is the definition of an exact differential equation? We are going to see. Exact differential equation. Exact differential equation. So what is an exact differential equation? We are going to study the definition. So before that we studied what is a total differential, how to find the total differential of a function f. Suppose m of xy into dx plus n of x comma y into dy equals to, not equals to, okay, is said to be exact if there exists a function, capital F. Suppose there exists a function capital F such that, how is that capital F? See, it will satisfy these conditions. That is, dou f, which is a function of two variables, and dou f by dou x equals to m, and dou f by dou y equals to m. So this differential form is said to be an exact differential form if there exists a function f such that this m is such that dou f by dou x equals to m and dou f by dou y equals to m. The total differential of this f satisfies the relation. See, what is the total differential definition? See here. So simply you substitute, in place of this we substitute m, and in place of this we substitute m. That is what we are going to write. The total differential of f is written as d of f of x comma y equals to m dx plus m dy, because it satisfies this condition. If this m dx plus n dy is an exact differential form, then this m dx plus n dy equals to 0 is called as an exact differential equation. Is called exact differential equation. Okay, so we studied what is a differential form of a function, then we discussed the definition of when we can say differential, this differential form is an exact differential form. Then if it's equal to 0, we call it as an exact differential equation. Now what we are going to do is, now we need to determine whether the given differential equation is exact or not. If it is exact differential equation, then we are going to find the function f. What is that function f we are going to find? So before going to the problems, we are going to discuss a theorem. What is a theorem? See here, the first order, if the first order partial derivatives of m and n if the first order partial derivatives of m and n, not dx, m and n, first order partial derivatives of m and n are continuous, then so m dx plus n into dy equal to 0 is an exact differential equation. It's an exact differential equation if and only if this condition is satisfied. Dou m by dou y must be equals to dou n by dou x. Okay. So the first order partial derivatives